Hi there. Today we're going to be talking about functions in the graphs. But this video is going to be focusing more on lines, and we're going to be talking about the slope, just like the basics, and then we're going to look at the line at the three forms: the point slope form, the slope intercept form, and the general form. We're going to talk about parallel and perpendicular lines, and in the next video I'm going to go over a real life application. So for the slope, the equation of the slope is y2 minus y1 over x2 minus x1, and for the slope we use the letter m. The letter s has already been taken, so therefore we kind of have to make do with the letter m. Also, just one thing that I would like to say is you have to stay consistent when you do the slope. So the slope would have to be y1 minus y2 over x1 minus x2. That would be fine because you're consistent. So the y1 minus y2 is pretty consistent with the x1 minus x2, but you couldn't do y1 minus y2 over x2 minus x1. So that would be a no-no because this is not consistent. You're being inconsistent. Alrighty. For the slope, you have to always know that we have a positive slope that goes upwards. So a line that looks like this is positive. A negative slope falls, so the negative slope would kind of look like this. And then I want to talk a little bit closer about the horizontal and vertical line. The problem that some students have sometimes is they cannot remember when which one's undefined, which one's zero. Let's talk about the vertical line. The vertical line goes up and down pretty much. And when you think of slope, you should think rise or run. So this vertical line does a lot of rising. It goes up and down pretty often. So let's leave the rising the way it is, rise. But the x coordinate does not change at any point. It's always going to remain the same. It does not do any running. It doesn't horizontally go anywhere. So let's substitute that with 0 because this thing never changes. So x2 minus x1 would just be 0 because the x's are all the same. So that would give you undefined because we know that we cannot have a 0 in the denominator. Because you cannot really hand out slices. If you have like 50 slices of pizza, right? We have 50 slices of pizza. Out of 0 slices of pizza, that wouldn't make sense. You cannot give someone 50 slices if you don't have any to begin with. And then the horizontal line. The horizontal line would have a slope of 0 because when we think of rise or run again, so the slope, you can see how this thing doesn't do any rising. It doesn't go up at all, up or down. So let's leave that as 0 because y2 minus y1 would be 0 since they are the same at any given point. But it does do a lot of running. It goes sideways. So we're just going to leave that as run. So that would equal to 0 because 0 over anything is just 0. So if you cannot remember that the vertical line has a slope of 0, undefined, and the horizontal line has a slope of 0, just think of rise or run. And that hopefully helps you out. So here's an example. Find the slope of a line from the given points. So if you have these 2 points, find the slope. So let's do this. File, new. Now the 2 points was 0, -10, and -4, 0. Finding the slope. Let's let this be y2 and that's y1. So 0 minus -10, and then since this is y2, this is going to be x2, so it's going to be -4 minus 0. We end up with positive 10 because -10 is positive over -4, which gives us -2.5. So that's how you find the slope. We have 3 forms. We have a point slope form, a slope intercept form, and a general form. So the point slope form, I will not really use it, the point slope form has been derived from the slope equation. If you remember, was slope equals y2 minus y1 over x2 minus x1. If you pretend that the point y2 and x2 y2 is a variable, meaning it's not a consistent point, it could be any point, you could see that it would kind of look like this: y minus y1. If you lose the number, you're not letting it be fixed anywhere. It's just a variable y. This could be any y. And x minus x1. And then if you have this equation, you could multiply both sides by, and let's get rid of this. Let's get rid of the middleman. You could multiply both sides by x minus x1, x minus x1, and voila, you have your y minus y1 equaling slope x minus x1. So if you don't remember this equation, it's just a slope equation, but it was tempered a little bit to make it look like this. Then we have the, and I personally do not like this equation. I never use it. I really like this one. In the field of physics and chemistry, I've used this equation quite often. So this one's the slope-intercept form. The reason why they call it the slope-intercept form is because you can see the slope and you can see the y-intercept. And then we have the general form. The general form generally has all the variables on one side and the number on the other side. So it could also look like 2a minus 3b plus 2c, I don't know, minus 7d equals 7 or something. I don't know. So for the general formula, we could have we need to have all the variables with their coefficients on one side and the constant on the other. Also, the coefficients should not be fractions. The coefficients need to be regular numbers. I can see my wife is blending something. So let's pretend that's not happening. Alrighty. We have we're looking for a line that has a point 0, -2 and slope 3. So let's do that pretty quick. New, do not save it. 0, -2, -2, and then slope is 3. Was it 3 or -3? 3, yeah. So I usually start with I mean, you can do this problem really easily using the point slope form, but I don't recommend using that form ever, you know. But I guess you should see it at least. It's my opinion. I should not have my students follow whatever. It's my opinion. I should teach everything, no matter how I feel about it. So to do this, we first plug in the slope. So y equals 3x plus b. And then we plug in this point into here, because the whole idea is we're supposed to have y equals some slope x plus some y-intercept. We have the slope, but we do not have the y-intercept. So to know what this is, we need to plug this into here. So this is the only one that's left. Since this is a point on the line, it makes the statement true. So we have -2 equals 3 times 0 plus b. So we end up with -2 equals b. So b is -2. So we have y equals, the slope was 3. And the b, the y-intercept, is -2. So you can drop the positive. So 3x minus 2. So that's how you do that one. And then we have a point and an undefined slope. Let's do that as well, because I care, you know. So new, bam, 6, -1, undefined. The thing is, over here, this is more logic rather than mathematics, because since the slope is undefined, I know that for the rise over run, the bottom had to be 0. So we're not doing any running, which means that this is probably a vertical line. So since this is a vertical line, let's say this is the x and y axis, and we know that 6, -1 was a point right here, that means, and we have a vertical line, that means that this is what the graph is going to look like. And what do we call this graph? We call it x equals 6. And the reason why we call it x equals 6 is because at any given point on this line, x does equal 6. And the same thing would have been true for horizontal line. If you had a line that kind of looks like this, let's call this is like the x and that's the y. And let's call this as x equals 5. I mean y equals 5. The equation would have been like y equals 5. You don't need to write this one down. I'm just saying that horizontally it would have worked the same way. Parallel and perpendicular lines. When two lines are parallel, they have the same slope. If two lines are perpendicular, their slopes are negative reciprocals. They're opposite reciprocals. So the way that works is, let's make this go away. When you have like a let's talk about a really steep slope. Not a undefined slope, because it's still going a little bit to the right, but it's really steep. So let's say this slope is like 11, right? So its slope that's perpendicular will kind of look like this. Ah, terrible. It's still going a little bit down as we go to the right. So over here you can tell that if I was right here, I would have a hard time climbing up. But if I was right here, walking down this way would be quite easy. So you can tell that this is very steep. However, this slope, the perpendicular slope, is not going to be very steep. Matter of fact, it's going to be the reciprocal. So 1 over 11. But also, this is a positive slope because it goes up as we go to the right. And this is a negative slope because we're going down as we go to the right. So that needs to be a negative as well. It's a negative reciprocal. So let's do an example. So find a parallel and perpendicular line to the given point and equation. So let's do that. Trying to get this done quick so you guys can go to the mall or play your sports or whatever you do. I know why I say or whatever you do. It makes it seem like I don't care what you do, which is partially true, but well, maybe it's not true. I mean, I would care if you guys did something not so I would care if you guys didn't do your homework. But if you go to the mall often, that really doesn't affect me very much. Unless I was working at the mall, then I see you a lot. Anyway, so to get this in order to do this problem, we need to a line that's parallel and perpendicular to this line right here. So in order to do this, we need to find the slope of this line. So in order to find the slope of this, we need to solve for y, because when you turn this general form into a slope-intercept form, the slope is very visible. So to get y by itself, I'm going to divide everything by -2. Y equals 2x minus 1.5 or 3 over 2 or 1.5. I should put 1.5. Let's put 1.5. There we go. Awesome. Alrighty, so 2x plus 1.5. This is pretty irrelevant. I don't really need this, doesn't really matter. But I know that the slope of this line is 2, and that's really all I needed. Because that tells me that the parallel slope, the line that's parallel to this one, is 2. It goes to this point, that's all I really need. The perpendicular slope is going to be the opposite reciprocal of this, so it's going to be -1 over 2. So let's do one at a time. Let's do the parallel slope first, because that's what A was. So we go y equals mx plus b. We plug in 2 for m. Let's just go ahead and rewrite this. And then we use the point, because that will let us know what b is. So that's 1 equal 2 times 2 plus b. So we're going to end up getting 4 here, and then subtract from both sides, we get -3. So our A is going to be y equals 2x minus 3. So that's, and my students should be boxing the answers. And then for B, same procedure, y equals mx plus b. Plug in the point and the slope. So 1 for y, the slope is negative a half, x is 2, and b we don't know. So we're going to get 1 equals, and that's negative 1 plus b. So b equals 2. B is going to equal 2. So our b will be y equals negative 1/2 x plus 2. That's it right there. Let me bring this down a little bit so you can see. There we go. Alrighty, so that's how you find the parallel and perpendicular lines. You just need to find the slope of this guy. Once you got that and you know you have a point, that's all you really need. Another example, determine whether these two lines are parallel, perpendicular, or neither. All I need to do is find the two slopes, because if they're parallel, the slopes are going to be the same. If they're perpendicular, they're going to be opposite reciprocals of each other. Neither would be, it's not parallel and it's not perpendicular. So let's do this pretty quickly. I always say pretty quickly, but it always does take me forever. I need to change my ways. 0, negative 1, 5, 9. And then line 2 is 0, 3, 4, 1. It's weird doing problems and talking at the same time. L1, L2, probably this. Grammatically, equations wouldn't, equal signs wouldn't make sense. It's more like use colons because you're about to have an anticipatory situation, or you're explaining yourself. Anyways, so to find the slope of this guy, y2 minus y1, so 9 minus negative 1, over 5 minus 0. So the slope for the first one is 10 over 5, which is 2. My students are going to have to do the actual thing. Does that make me a hypocrite? I do not know. But I am the one handing out the grades, so I guess don't really have a choice. And then 4 minus 0, negative 2 over 4, because the negative came from right here. 1 minus 3 is negative 2, which is negative a half. Bam. Anyways, you can tell that they are not parallel because they're not the same. However, if you took the 2 and did the reciprocal and then made it the opposite, you would get negative 1 over 2, which does mean that they're going to be perpendicular. Anyways, if this wouldn't have been the case, it would have been neither. Am I done? I am done. This is it for this video. Hope you guys are having a fantastic day and enjoy whatever you're doing. See you on Monday.